Hi, I welcome you all for another session. I think this is for Puneet's session today, but he is quite not well, so I'm taking care of it. Um, Meanwhile, I need your cooperation because I haven't checked the questions. So yeah, uh, let's take a couple of minutes to start. Shall we start, guys? Uh, So I'll share my screen for the first question. Okay, can you all see my screen?
Yes.
Okay, so the first question is construct a string from a binary tree. So we'll be given this kind of a tree, like a normal binary tree, and we need to change into this string form and how this string form is being generated. So for example, this is a node and its left part is 2 and so for and 2's again left is 4. So whenever there is anything on the left or right, it should be in a bracket. So 4 is in a bracket, and similarly 2 is also in a bracket, like for one's node, and right part of 1 is also in a parenthesis, like this is round parenthesis. So you need to make it like something like this. Before that, it mean actually it should be like this because there are empty two's right is empty, and similarly 3 left and right are empty, but you need to omit all the unnecessary empty parentheses. So it should be like in this form, and if you're generating kind of this as well, this needs to be omitted. And this is also the same example, but here they are saying that we can't omit the first parenthesis pair to break the one-to-one mapping relationship between the input and the output. So it's saying that there is a one-to-one mapping, so that's why they are not removing it. Um, but here they are removing it. So anybody has tried to solve this question? Anyone?
Even having any approach is also fine.
Um,
Hey, yeah, hi. So um, I didn't solve, but I have an approach for it. So what we can do is we can write a simple recursive program for it, in which first we will traverse the root node, then we will traverse the left part and then right part. And meanwhile, we will like maintain a string, and in that string we can like append the first root, then left, then right, in that
yeah,
way.
yeah, that sounds good. Like a pre-order, we can do it because we are coming because the output we need to give it in a pre-order. The only main thing is how we pass the parentheses over it. That's the main. So what would be the return condition for the for your recursion? What you're thinking about it?
Okay, so if um, the node is null, then we will just add empty parenthesis and return.
Okay. So what? I think I need to. mute some. Okay. So you are saying, yeah, so if the node is none, we need to pass the empty parenthesis. And how about passing the opening and the closing?
Okay, so if the node is not null, then we can first append opening parenthesis, then append the value of that node, and then append the closing parenthesis.
And is it like if we can get this kind of a condition, like we'll be adding the empty parentheses as well? Is there a chance to get this kind of a problem? Like tools right is null. So I'm thinking like something if we can use a stack or a queue, that would also be help. That would also help over here. Like for recursion as well, if we are passing the return at if the node is empty at every if the node is empty, then we are passing this empty bracket. Would it be easy to handle this condition? I'm just thinking about it.
I use a recursive function.
Mm-hmm.
Yeah, like just mentioned, if the root is none, we just return the empty string, and we think about several different situations. One of the situation is left. One of the situation is a leaf node. That means the left and the right are also none. In this situation, we will return the string of that number. And another situation is the left node is now none and the right node is none, like the example 1. Like the node of the left node of 2 is 4, but the right node is none. In the example 1, we can just return the string of the 2 and connect and the string of the left parenthesis and the string of the left node value 4 and the right parenthesis and plus the empty parenthesis. Yeah, like the explanation, it will be 2 parentheses, 4 parentheses, and empty parentheses. And the last situation is the left node is none, but the right node is now none. Like the example 2. The example 2, yeah, the node of 2, the left node of the 2 is none, but the right node is 4. Yeah, in this situation, we will put the 2 and empty parentheses and the node of 4 plus 2 parentheses. Yeah, that's my
Yeah, thank you. Anybody have any questions on this approach? Anybody wants to like to be anybody haven't understand this question or any approach? Because I think this would work, recursion would work, because or you can take any stack to solve this particular problem. Like,
so let me ask like one question.
Yeah.
What kind of traversal is best suited here? Like, will you guys go with in order, pre-order, or post-order?
I think it would be go for pre-order because we are going from top to bottom.
fact is given in the
It's
question.
pre-order as it is mentioned in the question as well.
Right.
It's a pre-order. It's
Yeah,
mentioned that like we want to print 1.
Yeah, with
Yeah.
the pre-order traversing way.
Okay.
It's written in a question.
Yeah, it's written in the question, but let's say like in the second example. Yeah, it will work. Okay, should be fine.
Yeah. So the only edge case is like if it is, we should not omit this particular bracket. If you are, so if your program is running like this only, your answer is coming in this way, then you don't, and if your parentheses are not coming, then it's okay. But if your parentheses are also coming, then that needs to be omitted. So that's the main question. Like if the recursion you are doing, your empty parentheses are coming or not. Anyone has tried to solve this particular problem if they got something like this.
Can someone share code?
Yeah. Julian has solved it. So can you share the code?
Okay. Yeah.
Like
I can,
understand, like help us understanding about how you written the code and how it is working. If it
okay.
stop sharing, if you want to share it.
Yeah. I can share my screen.
Okay, sure. Give me a second.
Could you see my screen now?
Yes.
Yeah, that's my solution for this question. I use the recursive function. If the node T is empty, I just return the empty string. If the node is a leaf node, that means its a left node and right node are also null. I return the T value string. That means the full number becomes the full string. Like we just return 4. Yeah. And another situation is left node of T is none, but the right node is now none. It comes to that example 2, like the node 2. The left node of 2 is none, but the right node is now none. In this situation, I return the node of 2 and empty parenthesis and the right node string like this. Yes. Yeah. In this situation, I return the 2 empty and the 4 with parentheses. This is the situation of this left node is none and right node is now none. And the last situation is like the example 1, this one. The left node is now none, but the right node is none. In this situation, we couldn't add the empty here. So we just, I just return the node of T and plus the left node number like 4. You can see here, there is no empty here. So we just return 2 and 4 with parentheses. And the last step is return recursively. Each step we will return the T value of string and left T left node and the T right node recursively. Yeah.
Is this
So
solution working? Have you checked it?
yeah,
Oh, okay. That's nice.
yeah.
Yeah. It seems like a good approach. Anybody have any questions? Anyone has tried on using any other approach?
Yeah, I was thinking of the use a stack or a queue to solve the problem, but it's not so easy to solve because you have to thinking about if the node is a left node or right node because they are different different solution parsing of the right node and the left node. So I
I
think
think what I am thinking, we need to take some visited part or something like that set as well while going for a stack. And in that stack, you need to like go for a pre-order approach. Then you need to go for, first of all, print the the node which is on a top, and then left and right. And while you are you need to check if it is left and right are is empty or something like that. Then I think that some logic would be there for this.
yes.
Yeah.
Mhm.
So anyone has any questions, then we should proceed further.
Okay, I'll stop my
Thank you so
share.
much.
Okay.
Yeah, thank you so much.
Mhm. Uh,
There's a, actually a variation for this one.
Yeah.
If you are already given this order, sorry, the output that we have generated here, can we
This one.
generate the tree out of it?
Okay. Mm. So seems like if it should be deserialized, for example, if deserialized in the form of a binary tree. So yeah.
Go ahead, please.
No, go ahead.
I guess like we can generate it because we know the root node, we know the left subtree, either it has a value or it is empty. Okay, and then we know the right subtree. It's a good question. Like try it out, but the way like we are constructing, we can like constructing the string. We can again construct the binary tree based on the if given the string. Because what I think if the left node is empty and we are not inserting the empty brackets, okay, then in that case it is hard to figure out whether the left is empty or not. But in this case, I guess yes, we can generate it.
The idea actually was just to understand why they want the brackets and even the left empty string, but not in the right one.
Yeah, because we can't generate like because if we have given like this kind of a string, we would have done that. But based on this output, we need to see which bracket is closed and which is not, where it is closed. Yeah, that would be the logic. Thank you, Puneet, for sharing this. Do you have any approach in your mind while solving it?
The first one or the
This one.
serialization?
This one, like deserializing.
The deserializing one?
Yeah.
Yeah, I think it is similar to how we construct a tree from pre-order and in order. The only difference in this case is you don't need in order to tell you what's going to be the next node, what is going to be the next left or right node. Anytime you first take the first element, that will give you the root node. Bracket start will give you the left node, and you can recursively continue till you are able to see a closing bracket for that starting node, right?
Okay.
Because that's your stack problem, the matching parenthesis problem.
Yeah, got it. Like going for a left part until unless you get some closing bracket.
Correct.
Okay. Okay. Yeah. That should work. Okay. So let's move on for another question. I'll share my screen. Let's see. Next question is top k frequent elements. Is it the same one which I have opened, like top k frequent elements? Can anyone tell me that? Are they able to
Yeah.
see the screen?
Yes.
Okay.
Yes, this is the
So yeah, it's the top k frequent elements. Like given a non-empty array, return the k most frequent elements. So for example, you have given this array, and you need to give the two most frequent elements, which is like 1 because its frequency is 3, and then 2 because its frequency is 2. And that's it, because you need to give the two elements. Similarly here. And they are saying that there is k number of unique elements, and your algorithm must be better than order of n log n, where n is the array size. Like better than order of n log n, not like above. It should be less than n log n. So anybody have any approach and have tried solving this question?
For this one, I use the count. I use a a map to count it, and you get a count and probably and get the top one, the top most two frequent. But
that would be but extra memory, and it's order of.
Oh, do they require constant memory?
Like it can be done if it is like that's one approach. I'm just like extra memory with order of n, and time complexity is also order of n, and it's better. The constraint, yeah. Like, can we solve it without using a?
Okay, without
How is
using extra memory, I'm thinking we can sort them.
Just a minute. How is this O of n time complexity?
Like maybe 2 of n, because you're saying that it needs to be creating a hash map where key is the number and its value would be the count of that number.
Correct. That will give you time to just create the hash map. You still need to find top k.
Then I think
you can iterate again through the hash map and keep the top two.
Oh, there's no top 2, there's top k.
Oh yeah, top k. So in this case, probably use the priority queue for the second.
Time will not be order of n then.
Yeah.
Yeah.
It will be order of n log n if you have to use the priority queue.
Yeah.
K, right? We have to involve k in here, not n log n, because we keep
only
at
the
most only k element in the
elements.
priority queue.
Makes sense, even better.
That's what the second point in the note says.
Then it would be, I think, log k, and which is less than n log n.
So we just under the assumption that the k is always less than the n, and the number of distinct elements are not always equal to the
K.
number of elements. So it will be around it will be around n log k.
Yeah. Yeah, which will be like order of n.
That's the worst case. In fact, if we go with the realistic situation where there are some duplicates, it will be less than n log k. But yeah, in the worst case, it will be n log k if all the elements are distinct.
So how can anybody explain like how they are trying to solve using a priority queue?
So once you have this hash map created, right, just insert each of the entry from hash map into the priority queue, right? And then what you can do is keep your priority queues a min heap. You will always have the minimum element on the top. And as soon as you see the size of the priority queue getting more than k, you can remove the minimum element from the priority queue. That will keep your size of queue always under the bounds of k. And this you can do for all the elements that you're in the hash map. Once you are done, at the end, you will have the top k elements remaining in the priority queue, which you can print out.
So you're saying we are using a two data structure over here, the hash map as well as the priority queue. My question is, can we do it without using a hash map? Just using a priority queue?
How? Now my question is, then your priority queue size will grow to the order of n. It can be done. It will again become n log n. And the problem says, can we do better than n log n? So essentially what you're doing, if your all elements are distinct, you'll keep inserting into the priority queue, right? And your size of priority queue will become of size n.
Yeah.
And then and then in that case, you will keep a max heap, and then you'll have to extract the top k elements. Right? And the insertion into priority queue for all the elements will take n log n time. The extraction will only take k log n, but insertion into priority queue will take n log n.
The other way I think it can improve the performance a little bit is not to use the priority queue. I'm kind of thinking using the what they call the partition in the quick sort, so that we can partition on the pivot, so to find k. So if we do that, then it probably going down to big O of n.
It will not come down to big O of n, because quick sort or quick select, the partition pivot of the element in itself can take worst case of O of n, and this will be doing for all the elements. So it will go to n squared.
Is it? No, we do the map, hash map first, right? When we have a hash map, and then we can do the quick sort. Then
let's assume the hash map has all distinct elements. It's all the elements in nums are distinct. So your hash map will always be the size of the nums. And then you apply a quick select on each of the element. That's what that is the reason why quick sort in worst case gives you a n squared.
Yeah, but in the worst case, it rarely happens, right? It like rarely happens.
It rarely happens, but I'm just saying from the asymptotic point of view, we need to, because a big O actually gives you the worst case scenario. If
we randomly pick the index, then it wouldn't be, n square.
Right. If we randomly pick the index, it may not always be n square, but I'm just talking about the worst case scenario.
Yeah.
The random.
Can somebody explain how it will work?
Sorry.
Like,
can somebody explain how the quick
about
sort and how it will work?
Sort? Are we talking about the quick select?
Yeah, can anybody explain this, how it would work in this particular question for using quick select?
I'll just give you a, I'll share my screen, just explain the basic idea of quick select, and then
Yeah,
probably it will automatically give you an answer.
yeah, I'll stop my screen.
Yeah. Assume you have a few numbers, 4, 6, 1, 4, 3, 5. Now what I'll do is I have to find top k elements. K, let's assume it's 2 in this case. Okay. And what I'll do is I'll get. So have you heard about the Dutch national flag problem?
Yeah.
Right. So similar to that, what we're doing is we'll keep one pointer here, which is j. We'll keep one pointer here, which is I. And then randomly among this, we'll select one element. Let's assume I'm selecting 8. This is called my pivot element. Now moving from left and moving from right, what I'll do is I'll move from here and find if there's any element which is less than j, right? This element is less than pivot. So it is less than pivot, right? And what is the first number which is greater than pivot? I find 12 is greater than pivot. I'll stop here. My I is here, j is here. I'll stop here. I'll swap those two elements. So now after this iteration, 4, 6, 1, 8, 5, and then 1, right? And then after that, I'll increment my both I and j. Increment my I, decrement my j. Okay, now again, I'm going ahead and trying to find an element from j which is less than my current element, pivot, which is 5, which is correct here, and an element which is greater than or equal to my current pivot, which is again here. Now, what I'll do is I'll just swap these two again, right? 4, 6, 1, 5, 8, and 1. Now you see, when I selected this pivot element has reached its proper position. Oh, not here, man, it's right here. Right, all the elements on the right hand side, they are greater. All the elements on left hand side, they are less than. Okay, so we don't need to, and our element or number, this index is 0, 1, 2, 3, 4, which is fourth element, right? And we have to find which one? Second. So definitely our answer lies on the left hand side. Or right hand side, all elements are greater, which may or may not be in order. Like we can have 11 here. We don't care about that. We just need to care about whether the index 4, all the elements greater on the right side or not. So now what is happening is this is getting divided into 2 arrays, right? And all the elements which should be on the right hand side are here, which should be on left hand side are here. I'll again perform the same operation on this part of the array using some random index again now from here, like suppose 4. My I will start from here. My j will start from here. Till the time I find my pivot or the pivoted element at second position. Once I reach my, once my pivot reaches the second position, I'm sure on the left hand side, I only have numbers which are less than the pivoted element, and on right hand side, they're all greater. Now this is, this is what I have done for finding the smaller elements or top k small elements. We can just, reverse the logic for the smaller and greater and find the same thing for largest elements also. Is this understood or might not be clear enough, but bear with me for today.
This is great. Anyone have any questions on this?
I have a trivial question on the previous hash map discussion. So for traversing the hash map, you take O of n, and for getting any values which are greater than or equal to k will be O of 1, right? So then why is that bad?
What is O of 1?
Why it is O of 1?
No, not why is it O of 1. It's better than n log n, right?
No, which one are you talking about? The first hash map?
The first approach that was discussed, like you just use the hash map.
How is getting top k and O of 1 question?
You are getting the values for k equal to 2 and k equal to 1.
sorry, let's assume the first example,
Yes.
right? And we
Yeah.
have 1, 1, 1, 3 and 2, 2.
Yeah.
So your hash map will be 1, 3,
Yes.
2 will have 2, 3 will have 1.
Yes.
Let me share my screen again. Or Sonia, if you could write the value. Let me.
Yeah.
So we have 1, 1, 1, 3,
Yeah.
2, 2, right?
Yeah.
So your hash map will have 3 entries. 1 will be 3,
Mm-hmm.
3 will be 1, 2 will
Yeah.
be 2. Right. And how will we find the top k elements here in O of 1 operation? Let's assume k equal to 2.
Oh, okay.
I understand the confusion because the input in the example is given sorted.
I see. Okay. I get it.
Yeah.
Another thing is like if you can take a tree map, then it would always assorted, and you can take something like that reverse one. But the only problem is it's again n log n.
Right. Tree map is also an acceptable approach if you are okay with n log n.
Yeah.
Can we do better than n log k?
Sorry?
Can we do better than n log k?
Better than n log k would be trivial, I would say.
Then I think we need to do the quick select thing.
Can you repeat?
I think then we have to go with the quick select way. Quick select.
Quick select can also go to maybe
N square.
n square.
No. In the worst case,
Yep.
yeah, in the worst case, it may go to n square.
So what's better than n log k? Is order of n, correct?
Right.
Yeah.
I don't think we can do that unless until we at least once go through the entire array.
Can we do bucket sort?
Bucket sort, it would be extra memory.
Yes, it will be extra memory because either you are creating the heap or the buckets. It's the extra memory.
How much extra memory? Because here the extra memory of using a hash would be also be less because they are frequent elements, and queue would also be less. But
Yes.
taking a bucket sort, how much memory we need?
Yep, I agree with that, but like the question is not talking about
The problem is,
about the time content.
for the bucket sort, I don't know the size of buckets.
Yeah, so
That I have to. I still need to know the distribution of elements for this.
so how many buckets like we will need?
Like for example, in first we need 3 buckets.
Yes, but like given array of n elements, okay, how many maximum buckets like we will need?
In a worst case,
The
it would
maximum count of any single element.
It should be
Like the count of any single, the max count of any single element.
yes, it should be count of like number of elements in the array. Okay, because assume all the elements are like in the first example, like we have 5 elements or 6 elements, and all the elements are 1. Okay. So 1 is occurring how many times? 6 times.
6 times.
Okay, so you need a bucket from 1 to 6. Okay, bucket with size 1, bucket with size 2, and up to 6. So you need like 6 buckets at max. Correct?
Correct. Yeah.
Okay, then create an array of an array. Okay, where each element in that array is a bucket. Don't initialize them in the starting. Okay, makes sense. And once we are iterating over the hash map, which we have already created, start putting the elements based on frequency. So let's say like we find 1 in the first example, 1 or 3 times. Okay, find the index at location 3. Okay.
Mhm.
Bucket is empty, like null. Create a bucket. Okay. And then put 1 in that bucket.
So is that possible that we can have a same number of frequent elements?
Yes, you can have the same number of frequent elements. So let's say in the first example, we have 3 ones, 3 twos, and 3 threes, and you have to find our top k, like top 2 elements. Okay. Okay. So you can return either 1 2, 2 3, or 1 3.
So you're saying we'll go for the index of that 3 and take, and in that bucket we'll be having all the 3 elements, 1, 2, and 3.
Yes. So
Okay.
so the idea is like create the buckets as you are iterating over the hash map, put all the elements in the respective buckets, and then iterate the array of buckets in the reverse order. Okay, so wherever we find the first bucket, let's say which contains the number of elements occurring in the highest frequency, see how many elements are in that bucket. Okay, if let's say there are only 1 element, okay, take all the elements from that bucket and then find the next bucket with the highest frequency.
I think this will work if the elements are sorted.
Why do you think so?
Otherwise, otherwise I again need to get a hash map to get the frequency. So if I'm
Yeah,
creating
we
a
need a
hash
hash
map,
map for the frequency as well.
Yes, like we need a hash map for sure.
okay,
But,
okay.
but after creating a hash map with each element with the respective frequency, bucket sort them.
Mhm. Okay, so if one element has frequency of 1 million, that means my number of buckets could be 1 million.
Yes, but let me like share my code also. Okay, so it will make like more clear.
Yeah, you can share now.
Yep. You guys can see my screen.
We are seeing the wallpaper.
Just the wallpaper.
Okay. Give me a sec. Looks like I need to allow Zoom to give like some permissions. Just give me a sec. I need to rejoin.
Can we go to next question and come back to this question at the end?
Puneet, can we do so?
Yeah, no issues. We can go ahead.
I think Gaurav joined.
Yes, it looks like now I can share my screen.
Yeah.
Can you see my screen now?
Yes.
Okay. So the first logic is same. Okay. The one that is selected. Here we are creating a hash map and counting the frequency of each element. Correct? Okay. And then what we will do, we will create a list of buckets because we need n buckets. If the size of array is n, we need +1 because it can go from 0 to n elements. Then start iterating over the hash map, get the number, get its frequency. Okay. If the bucket at that frequency is null, initialize the bucket and add the number in that bucket. Is it clear? Up until here?
Yeah, it's clear.
Okay. So by this time, until line number 26, what we have done, we have initialized the respective buckets that we need and put all the elements with the frequency in the similar buckets. Okay, so in this example, what we will have in the first example, we will have 4 buckets, bucket with size 0, 1, 2, and 3. So in the size 3 bucket, 1 will go, in the size 2 bucket, 2 will go, and in the size 1 bucket, 3 will go. Okay.
Yeah.
Then start iterating the buckets from the these buckets from the last. Okay, pick the last bucket which has the elements of highest frequency. Okay, and check if that bucket is null or not. Okay, so in this case we will pick the bucket at index 3 first, right? And then check how many elements are in that bucket. We only have one element, which is 1. Okay, add that to a result, pick that number. Okay, now we need like one more element, so iterate again, go to the second bucket and take the second element, one more element, and then we are good. Okay, because this question says you can return any 2 numbers which are most frequent. They are not requiring the number in any sorted order or any like lexicographically increasing order or decreasing order. So we are good. We just need to pick the top 2 numbers. Any questions on this?
And will this work if we have like constraint that get the top 2 or top k based on the lexicographical order of the numerical value?
Yeah, then it will not work, because then what we will need to do, we can still do the bucket sort, but then in each bucket we need to sort the elements.
We need to sort each elements, right?
Yeah, like in each bucket. Okay, which will be again order of n log k. Because assume like in the worst case, let's say if all the elements are in one bucket only, yeah, it will be n log n. Okay.
You start from last because the most frequent elements will be at the last position. That's why.
Yes, because we have initialized the buckets from 0 to 3, and at the index 3 we are putting all the elements which are occurring thrice.
Okay.
Okay.
May I ask what's the time complexity for this solution?
Okay, so let's calculate it. What's the time complexity of creating a map?
It's all of n.
Okay, what's the time complexity of iterating over the elements in the map and then putting them in the bucket?
All of n.
Okay, so these two combined says order of n.
Yeah.
Okay, what's the time complexity of iterating through each bucket and then picking each element?
Okay, it's all of k, I think. It's no need to iterate the whole bucket. It's just need to pick up the k element in the bucket.
Yep. So order of n plus order of n plus order of k, which should be order of n.
All of n. Yeah. Great. Yeah.
Okay.
Yeah, it seems like a great approach. Thank you so much, Gaurav, for sharing this.
Yeah, no problem.
Yeah. Shall we move for the last question? Anybody wants to discuss anything? Okay, so we'll go for the last question, and the last question is sort colors. Puneet, can you explain this question? Check this question actually.
Essentially what they're saying is you are given objects and they're colored red in 3 different colors, and you need to sort them in place so that the same colors are with each other and there's a specific order given to specific color. Like you need to have first red color objects, then white color objects, and then blue color objects. And for simplicity, what they have done is given integers to each of the color. like 0 for red, 1 for white, and 2 for blue. And let's assume the numbers. So if you can see the input, you have 2 0 and then 2 0 2 1 1 0, and the output has to be something like 0 0 1 1 and 2 2. 0 representing the red color, 1 the white ones, and 2 the blue ones.
It seems like it's kind of a Dutch national flag approach question.
Yeah, it is Dutch national flag only.
Yeah.
Just a different way of saying for the same problem.
Yeah. But they are saying you need to come up with one pass algorithm using constant space.
And how much is the time complexity for Dutch?
I am not sure.
If anyone has gone through Dutch national flag, could you just explain to everyone else, like for the benefit of everyone on the
Yeah.
call?
Anyone has tried this question?
I believe like we just explained this question a while back.
Yeah, that's why we were discussing.
Yep, because this is the same as Dutch national flag.
Yeah, and I just want to ask that quick select approach would work best over here, correct?
Quick
Sorry,
select
which
like, yeah, go ahead.
Sorry,
Please.
go ahead. Something else.
Will quick select work here?
Yeah, my question is this.
What do you guys think?
Because it,
What does quick select do? That's
Yeah,
the main.
that approach which we were discussing last.
I believe a quick select is a different approach where we are trying to partition the array based on the pivot. Okay, so the elements on the left are lower, elements on the right are higher than the pivot. But here we are trying to do the similar thing, but instead of pivot, it can be a range. So yeah, so you need to have like 0 0 and then 1 1 1 1 and then 2s. So I'm not sure like quick select will work here.
Actually, quick select can also work here, but it will not be as efficient as Dutch national flag. Can someone kind of guess how we can implement a quick select and get this thing? Sorting of 3 colors, but using quick select. It may not be optimal. That's fine, but just to relate quick select to this problem.
I have one question. So they are sorting them on the basis of the frequency, not on the basis of the number 0 1 2, correct?
We are sorting them based on the color.
Like
Just
frequency of the color or the
No, there's no frequency. It's just colors. The same colors should be along each side. And the first color that should be in the array should be red one, which is 0. Second is white, which is 1. And third is blue.
okay. Okay, whatever the like for example 0 is 4 and 1 is 2, it doesn't matter.
Yeah, it
Yeah,
doesn't matter.
it doesn't matter. You can have like the red color, like the first color, whatever is representing 8. Second can be 2. Third can be, let's say 9. Okay, so your result can be 8, 2, and 9 in order.
Okay.
Yeah.
Okay. Okay. So anyone wants to discuss the approach?
I have one idea. I think this is similar, like to me, like the moving all the zeros at one end, and then what is the next color we move that color to the other end. So there is a standard problem, like move all the zeros to left or right. If I can try that, I can move one color on left side and the other color on the right side.
So can you try this on the current input set? Just try it out.
Sorry, I couldn't get you.
So could you simulate your algorithm on the input that you can see like?
So just trying to understand, like you guys told like it could be different numbers also for the colors.
Yeah, it can be any color, any three numbers. Like it can be 3, 4, 5.
But what order we have to select in the?
So let's assume the smallest one is the first, then the next
Okay.
higher. And
So it could be any three numbers. The smallest would be on the left.
yeah, let's assume that way.
Okay. Let me
So
try
what should,
to.
what should be the brute force approach?
Brute force is like sort them, I think.
No, like the question doesn't say that. Okay, let's say I have a number 8 representing some color, then 2 representing some color, and then 9 representing some color, and I want like all the 8s to be first.
Mhm.
Okay, I'm not sorting them. 2 can come after 8s. What I need all the 8s to be in first place, all the 2s to be in the middle, and all the 9s to be in the last. Okay, so it's like not necessarily the sorted array.
Yeah, but then they have to mention like what order it should be.
Yep. So take my example. Okay, like how you will bring all the 8s in the first, all the 2s in the middle, and all the 9s in the last. You cannot like sort the array.
Yes. So in that case, they will also tell the order. So we are doing one more level of complexity here.
Yep.
Because in this question, it is not mentioned. I think so.
So just like what the brute force approach, can't we just like move like pick the first number which need to become first, iterate through the array, and then bring it to the start. Okay. While we are done with the first pass, okay, all the numbers, let's say zeros in this case are at the start, and then 2s and 1s are like maybe in some random order. Okay. Now,
But you're also telling take an extra array first.
no, like not take an extra array. Iterate through the same array. Okay. As soon as we find 0, have 2 pointer approach. Okay. Have a start index and then the next index, like which will keep like moving forward. Okay. As soon as you find a 0, replace it with the start index and jump the start index by 1. Okay. So by the first pass, once we are done with the array, what we will have all the zeros in the first place. Okay. And then 2s and 1s, they might be in any order. Okay. And we also know at what index we wrote the last 0. Correct? Okay. Then from that index, we can again repeat the same process, bring all the 1s to the first and then 2s to the end. It's a 2-pass solution.
I just want to ask, you are saying it's for like in the first pass, we'll take one index. And if we are taking that, if we are replacing, for example, here 2 with the 0, then this count of 2 will get replaced.
No, like, so you have, let's say you have 2 and 0. Second element is 0. Swap them. Okay.
Okay.
So I think it's the same like what I was mentioning, like moving first, like the problem, like where we want to move all the zeros either to left or right.
Yep.
Yeah, got it.
Yeah, so we can do it in like 2 pass.
But that because we know we'll be having one element at the end, so we are just considering all the elements moving further. But here is like if we are taking that particular problem, here we need the swap logic as well. I think the other question
I think we don't need a swap logic. What Gaurav is mentioning, like we know what needs to be on the other side. So keep on moving things, and then just overwrite whatever is at the end with what you need.
How can we like the last time you shared the screen with a whiteboard? How to do that?
You click share and then click. Oh, so somebody has to stop sharing.
I have stopped sharing, and you need to go to the share option, and there is a whiteboard as well.
Okay. Now I found. Can you guys see it now?
Yeah.
So our array is 2, 0, 2, 1, 1, 0. Correct?
Mm-hmm.
Our start pointer will start from here, and then like we have 2 pointer I and j, let's say. Okay, then move the second pointer at this position. If we find a 0, swap them. So it will be 0, 2, 2, 1, 1, 0. Okay, now then jump, like after swapping, move the start pointer one ahead. So our start pointer is now here, and then the I and then the j is here. Then move j like one location. Okay, here it's not a 0. Move again, it's not a 0. Move again, it's not a 0. Move here, it's a 0. Swap this number and then this number. So it will be 0, 0, 2, 1, 1, 2. Correct? And by this time our start index is here, the I, pointer I. Okay, so we brought all the zeros to the start. Correct? Now repeat the same process on this array. Initialize the I from here and j at the same location. Okay, and then repeat. So in this case, when we move the j, okay, we find a 1, so we will swap 0, 0, 1, 2, 1, 2. We will move the I and j is already here. Then move j 1 index. Okay, we again find 1, swap them 0, 0, 1, 1, 2, 2. Okay, keep going. We reach the end. We are good. So in the 2 pass, all the numbers are sorted or like move to the location that we wanted.
Yeah, that sounds one approach to me. Yeah. And this can be done in one pass.
Yep, this can also be done in 1 pass. So this is a 2 pass solution.
Mm-hmm.
What's the time complexity of this one?
Order of n, maybe? No.
Order of n for the first pass,
First
and
pass,
then
yeah, more than.
order of n for the second pass. So total is order of n.
Yeah.
Okay. And then can someone explain how we can do it like in 1 pass?
If you add one more pointer, maybe you can do it with 1 pass. Yeah, yeah. One pointer point to the first color and another point to the last color. Yeah, when you iterate the whole array, if you see the 2, you swapped with the last color. If you see the 0, you swap with the first color. If you see 1, you keep this stay.
Do you want to explain?
Okay, yeah. Whiteboard.
I believe like we are over time like 5 minutes, but I guess it should be okay for you guys.
Okay.
Don't worry, it's a normal thing for us. Like we usually go up by 15 minutes.
Okay.
Yeah, I have the example is 202110. Okay. Like the example is 202110. I have 2 pointers. One point is like the first. The last, another point is point to the last color, so maybe L. and we iterate the whole array from the start. It's I iterates the whole array. If the I equals last color 2, we swapped 2 and this one. That means this is a 0, 0, 2, 1, 1, 2. And this is, and the L move backward one step. And this time I point to the second element here. And it points to the 0. 0 is the first color, so we swap towards with this one. 0, 0, 2, 1, 1, 2. And the first color points to this position. This is the first color. And at this time, I move to the 2, and we see the 2 is swapped with the last color. So we get the 0, 0, 1, 1, 2, 2. And I move to this one. When we see the middle color, we didn't do the swap, and we keep the I moving forward, and we didn't swap here because it's already equals the last color. Yeah, I can show my my code. Maybe it's more easier to understand how to implement the one pass.
Sure.
This solution is great. This is what is called like Dutch national flag sorting.
I didn't know that name. I just use a pointer. Yeah, if we, I remember I solved a similar question like a requirement to do the one pass sort and with constant space. So you can't create a new array to store your sort results. So I usually use the pointer to swap them. Okay, I'll share my stop sharing. Yeah, yeah. This is my code. I have the 2 pointer. One is point to the 0 position, and one pointer named 2 point to the last of the array. So in this for loop, we keep I moving forward, and if the number I equals 2, that means this is the last color. We swapped the current num and the last color, and we move the last color -1 here. And if the numbers I equals the first color, we swapped with the 0 point, and keep the 0 point move forward by 1. Oh, sorry. Have any question? Hello?
I will try myself and try this thing. But yeah, this is a good one.
I just have, that one question again for everyone. How can we apply quick select to solve this problem?
Select sort. As we
quick select and go ahead.
Yeah, as we discussed before, the the 0, 1, 2 is represent 3 color. Maybe the 3 color is not in increasing order. Maybe the red, white, blue is like red is 1, white is 0, blue is 2. So in that case, we cannot use the select sort or quick sort to sort them by the value of the element. And another thing is if we use the select sort or quick sort, the time complexity is only n log n. So,
I'm not just saying, I'm not talking about the best case scenario or best algorithm. I was just trying to see how we can relate a quick select algorithm to this one.
What I believe like quick select is like not going to work here because quick select is not a sorting algorithm. Quick select will give you the max n numbers, k numbers, or like min k numbers in order of n in the average case, n square in the worst case. I don't think like you can sort it based on the quick select.
But we only have 3 values here. So if we can just take, like, suppose, let's say 1 as a pivot element, get all the zeros on left hand side, 1s and 2s on right hand side. Now our problem reduces to right hand side section and just take pivot as 2. I hope that is clear or not. I can show the screen too. So suppose we have
I'm not very sure.
Let's take our pivot element as 1. Right? So for sure we can have all the elements 0, 0, 0 before that we are sure, right? And we can have some set of numbers here. It can be 2, 1, 1, 2, anything, right? So we have sorted one set of, we have moved one set of numbers to left hand side. Now problem reduces to quick select on this set of problem with pivot as 2. And then we'll have 1, 1, 1, and then 2. So sorting this one by one. I'm not saying it's a classical algorithm with very good time complexity, but just how we can relate quick select to getting this problem solved. Is it still confusing? Hey guys, am I audible?
In this case, like 0, anything which is, so you'll consider like 0 is also smaller than 0. So anything that will come to left side, other things will go to right. Then you'll take 1. Anything
pivot
like
here is 1. 1 is a pivot element.
Mm-hmm.
So anything which is less than that will go in the left section. Right? That's what pivot, the quick select does. It will take the pivot.
Yeah, but if you're taking 1 as a pivot, still there's no guarantee 0 and 1s could be mixed up.
Yep, because what if you select the pivot as the second last element?
No, I'm saying to select 1 because we know if we have 0, 1 and 2. Let's not say 0, 1 and 2. Let's say black, blue and white. Right? If I select the first one, I need to get zeros, or suppose reds on the left hand side. What is the next element there? Suppose it's white. So I'll select white and push all the blacks to the left. And then I'll select blue, which is my last element. And then and my problem is only this much now. I have solved for this one. So this one I'll not consider index as I2. I plus
in either way, this is as good as what we just discussed. Like Gaurav.
It's same as that one. I'm just saying how we can relate it to quick select.
See, so the other approach which we discussed in quick select, they're both 2-pointer approach. So they will share the traits, obviously.
Right.
Like in a 2-pointer, that's now it's how it depends how we play with the 2 pointers. So definitely quick. See, I see like quick select. Anybody who wants to try with the are not familiar with two pointer and want to brush up how exactly that work, quick select is a really classic example how two pointers work. That's what I feel. So if somebody does not aware about how to play two pointer, get it started with quick sort only. That's what I advise. And then it can be applied to other examples like moving zeros to left or right, or this example problem we just discussed.
I think we are about time for today.
Yeah, seems
anything
like
else, guys?
anybody wants to discuss anything? I'll stop recording.